formulas. So make sure your calculator is in degrees, please. Degrees. Yes. Okay. Here we go. Notice that I put the important stuff on the first page, so that way you can just look at the formulas today, right? So here we go. First formula. All right. The dot product or the scalar product. We kind of had a preview of this. So let's say vector B has components B1 and B2, right? And vector W has components W1 and W2, right? To do the dot product, B dot W, don't say times, okay? The dot product, yeah? This is just B1 W1 plus B2 W2. You multiply the components and then add them together. The product is a scalar, right? Important notes about this one. This is the big formula. Okay? Star. If the dot product, so here's a note, right? If the dot product of B and W is 0, that means the vectors are perpendicular. Okay, so if the dot product is 0, that means they're perpendicular. Okay? Okay. Trust me. What is this measuring? Okay, let's put it. Yeah. Hang on. I know, it's really hard to go one side. It's gonna happen. It's gonna happen. Set these answers all at once. Okay, here we go. Second formula. Big formula today. To find the angle between two vectors. Right? This formula is in your formula packet. It's cosine of theta is equal to the dot product of the two vectors, so B dot W, divided by the magnitude of those two vectors. So magnitude B times magnitude W. Notice in vectors, if you want to multiply, just put them next to each other, it's not dots. So that's why I differentiate between the dot product and the vector product. So this, my dear, finds the angle between two vectors. Okay, and that is definitely the formula packet as well. But you'll do it so much that you'll just know it. Right? Okay. Note about this formula. Another note. Okay? Yes. You will know that the vectors are perpendicular, right? In other words, like this, right? Vectors are perpendicular if the cosine of if the angle is 9 degrees, because once the cosine is like 0, and I should not say if, it should be when, right? In other words, right? If theta is 90 degrees, okay, then the cosine of theta, which is d dot w over p magnitude and w magnitude, the dot product would have to be 0. In other words, p dot w had to be 0, because when p dot w is 0, then the vectors are right? Yes. What's that? What's up? What's up? What? Oh, yeah, this is perpendicular side. Here. Yay? Okay, so let's do a couple of tests. Are the vectors perpendicular, parallel, or neither? Ooh, we didn't even talk about parallel. Yeah, we did. Yeah, we did. Remember, did vectors have to be the same size as parallel? Haven't so. Here's how you check to see if they're parallel. Ready? Does anyone still right? Alright, here we go. Parallel, perpendicular, or neither. Okay? First, check to see if there's any scalars. A is negative 3, 4. B is negative 212. Is there a scalar for either of them? 212 has a scalar, right? B has a scalar of 2, and the components are then 6 and 1. Notice that A has no scalar. It's still negative 3, 4. This way, right? Now all you do is compare the inside. Highlighter, highlighter. If this, hello? Oh, no, that didn't work. Silly smart board, not so smart. Yeah, if this and this are the same, then they would be parallel. But since they're not the same, they're definitely not parallel. Because they're not the same. Yeah. Components. Yeah. They would have the same components, take away any scalars. Yes, love? Did I do a parentheses? I am sorry, Sonia. I just yeah, it should be. Yeah, no, my bad. My bad. Okay. Now let's see if they're perpendicular. How can we check to see if they're perpendicular? If they're equals 0. Let's check. Let's check. All right. Let's do A dot B. Okay. All right. So the components are negative 3 times negative 1 plus 4 times 2, which is plus 4 plus 11, which is not 0. What is it? What did I do? Oh, no, I did the first one. Sorry about that. 4 times negative 12. Yeah, sorry about that. Negative 3 times negative 12. 4 times 2. Sorry about that. 36 plus 8 is... Nope. That's trying the angle. No, good call. Yeah, that's later. We'll do it later. Yeah, to check for perpendicular, you just have to find the dot product. Sorry, 40 what? 36 plus 8 is 44. Yes, love. Yes. Yeah, if there's a scalar and then their components are the same, then they're parallel. If they're not parallel. If the dot product is not 0, then it's not perpendicular. Therefore, either... I saw a hand. I saw a hand. Vinay, is that you? Question? No? Yes, my love. Earliana. I didn't spell neither. I before E? They lie! They lie! Why do they make up that rule and then there's all these excepts? Thanks, Earliana. Alright. We good? Okay. I can't spell. Here we go. I'm so dyslexic, one time I walked into a bra. No? Huh. Parallel, perpendicular, neither. Here's 3 of them. What? parallel for our 15th year. Any scalars? B and Y, let's see. B has a scalar of 10, so it's 2 and 1, right? And then Y has a scalar of negative 3, I like it. 2 and 5, sure. Negative 3 can be a scalar, yeah. Let's just go in the other direction. Ah! Yes! So according to this, highlighter, 2 and 5 matches up with this one, this 2 and 5, because the 2 and 5 are the same. So that means W and Y are parallel. And if they're parallel, they're obviously not going to be perpendicular. So you have to check the other combinations. Let's check W and B. So W dot B is going to be 2 times 20 plus 5 times 10. That's a 5. 40 plus 50. Yeah, that's not 0. So not perpendicular. True. There's one more combination. There's one more combination. Oh, and since U and B are parallel, all right, yeah, you're right. Right. Since W is parallel to Y, then Y cannot be perpendicular to, I'm just making this up, B. Yeah, there you go. So the only things that are parallel are W. Joy? Joy. I told you this was good. You can write it out or whatever. Yeah. You want to spell it out? I can do that too, but I can't spell. So, alright. Here's a classic IB question. You got two perpendicular vectors, and you're missing one of the components. What do we do? Allah! Set the dot product equal to 0. Yeah. How do you do that? Excellent. Since we know they're perpendicular, that means the dot product of C and D is equal to 0. Therefore, 7 times x plus 4 times 12 is 0. 7x is equal to negative 48. So x is negative 48 over 7. You can have that? Yeah, you can. Yeah, you can. Yeah. Oh! I'm so excited for this next one. Okay, I wait. Let's see. Oh no! Okay, x. Good idea to put them next to each other. I don't know. I'll stand a second. Alright. Let's do a 3D vector because it's Trey's favorite. Yeah! Yeah! What? Okay. Alright. Can we agree, Lord? Here we go. Can we agree that the first vector has a component 3x plus 1, 1, and negative 1? True? And the second one, because it's a 3D vector, is x plus 3, jk, 3, and negative 2. JK! Right. So it's the same thing, make their dot product equal to 0. So V dot W has to be 0 if they're perpendicular. Boy, we can do some algebra. Okay. 3x plus 1 times x plus 3 plus 1 times 3 plus negative 1 times negative 2. Oh my god, we're going to have to slip and slide. Oh no. Ooh. Then it said dot slip and slide. Just wants you to slide and divide. What is one? Oh, don't call it FOIL, call it distributive property. Well, look. When you slip and slide, do you get the right answer? Yes. What's that? Either way. Yes. Yeah. Yes, love. Oh! Did you have Craig? Slide and divide. Sorry. Yeah, slide and divide. Slide and divide. You have to solve this equation. Ready? Alright. Here we go. The first part. Yeah, it's good. Can you do these quickly in your head? Here we go. This is 9x squared plus. Not 9x squared. I'm already thinking ahead. Here we go. 3x squared plus, whoa, 9x plus 1x is 10x plus 3 plus 3 plus 2. Did I go too fast? Is it okay? We're good? We're good? Okay. All right. Here we go. There are 2 solutions. There are. Here we go. 3x squared plus 10x plus it. All right. Okay. Slip and slide and divide. Slide and divide. Here we go. Plus 24, right? I'm going to just keep that 0 out of there. Break it up, break it up. X plus 6, x plus 4. Hello. Divide by 3 equals 0. So I'm going to leave it in that form. What's x? 2 and almost 2 is not 2. Negative 2 and negative 4/3. So x is negative 2 or negative 4/3. You can have 2 possibilities and it would make that vector perpendicular. In other words, probably what's happening is, right, you have your regular vector that's going like this, right? Or you could have the one on the other side going like this. So that's why there was a split. Me gusta mucho. All right. No. No, let's find angles. All right, here we go. Warm up those calculators. Get them ready. Get them ready. What? Oh, I'm so glad. I'm so glad. Here we go. Ah! All right. Ooh, 7? Did you hear about 7? Shape 9. All right. Here we go. No. 7, 8, 9. No shit. Here we go. All right. So, to find the angle between, you need a couple things. You need the dot product and the magnitude. May I suggest you find the magnitudes first? Okay? So first off, find the magnitude of V, which is 6 squared plus 3 squared, which is 36 plus 9. Yeah, what is that? What is that? All right. Yep. 3 or 5? I don't know. All right. W. Square root of negative 1 squared plus 4 squared. Square root of 17. All right. Step 1, find the magnitudes. Here's why. The dot product is easy. You just write it out. So it's going to be the cosine of theta is going to be the dot product of V. Sorry, that's the B. Dot W over V W. Folks like that. Magnitude. Right? So V dot W is going to be 6 times negative 1 plus 3 times 4 over root 45 times root 17. Actually, let's just do this. That way I don't put any more dots. To solve for theta, second cosine that puppy. That's it. So this is calculator ready. That's why I didn't make you do all that crazy stuff with the radicals, because you don't need it. You don't need it. All right. So here we go. On your calculator, second cosine, right? There's even, if you do alpha y equals, you can do fractions. And just type it in. So 6 times negative 1 is negative 6 plus 12 at the top. Oh, alpha y equals. Alpha y equals. Okay? And then square root of 45. And then square root of 17. Go back. Yeah? Oh, I did that. No. What? You didn't even check. Go back. Alright. Second, quit. Clear. Try this again. Second, enter. Yep. Is that right? 77.47? Yeah. Are you in radians or degrees? You're in degrees. Okay, so what did you put in the top? Oh! Okay, so second cosine. Alpha y equals. Nope, it doesn't. Okay, so you have to actually plug it in. Sorry! No, you're good. You're good. So when you do second cosine, just put this in parentheses divided by this in parentheses. You can do it. You can do it. Huh? It's to do with multiply. Right? Alright. Well, I should do ish. Ish. 77.471 degrees. You got 63.86? You don't want to see. Parentheses. Root. Oh, you didn't close the root 45. You have to close it. Because otherwise it's taking the root 45 times like the root of 17. Yeah. She's alright. She's like alright. You can do it. What do you think, Miss Penang? Better! Yeah. Make sure you close the roots. Alright. Woo! 3D vectors. Yes! Okay. It helps if it's in component form. So the first one is. Alright. And the second one is. Joy. Component form. Okay. Here we go. Magnitude of B. Square root of 2 squared plus 1 squared plus 1 squared is square root of 6. Right? Magnitude of, are we good? Magnitude of W, 1 squared plus negative 1 squared plus 3 squared. Square root of 11. Yeah? Okay. So cosine theta, and I'm not even going to write the dot product. Let's just put it in. Here we go. 2 times 1 plus 1 times negative 1 plus 1 times 3 all over root 6 root 11. Solve for theta. Oh, let me clean this up. Might help. This is 4 over root 6 root 11. Yeah. Actually, 6 times 11 is 66. You could just put 4 over root 66, right? Gosh darn it. 4 over root 66. Second cosine. What is it? Yeah, to 3 degrees, please. Decimal. that right? Is it 16.504?
Yeah.
Okay. Woo! No snapping.
Oh wait, is it 4?
Yeah, that's a 4. Sorry, that's a 4. Is that right? Did I mess up? Yeah, that's a 4. Okay. All right. Let's bring it together now. Okay. Coming back to full circle. Here we go. We're back to right now. Here we go. The angle in the middle is key because that's how you set up your vectors. Okay, so we have two vectors. We have AB and B and AC. So you want to make sure that the angle is the first letter in your vectors, and you just go on the opposite direction for each vector. So here we go. Remember, first of all, we need a vector AB, right? To do AB is just B minus A. Remember that? Right? So let's do it. Negative 5 minus 7 is negative 12. 6 minus 3, 3. There you go. So AB is negative 12, 3. Yeah. And the next one, it has to go AC. Because again, A is the middle, so it's the start, it's the initial point of the vectors. Right? Which be C minus A. Okay. 12 minus 7, 5, and 5. Okay. So now we want to find the angle between this. So this is what theta is. Yay! Yeah? So theta is going to be inverse cosine of the dot product. So negative 12 times 3 plus 5, sorry, 3 times, nope, negative 3 is 5. 5. And then plus 3 times 5 divided by, did I forget to find the magnitude? Gosh darn it. AB. The magnitude of AB is the square root of 144 plus 9 is, what is it, 153? Yeah. Good. And the magnitude of AC is going to be 25 plus 25. Okay. So square root of 153 times the square root of 50. Okay? And if you want to make it even more calculator ready, you can just simplify the top. So what's that? Negative 60 plus 50. Something, something, dark side? Yeah. So negative 45 over that. And the angle is 120 point. We got 964. Is that right? 120.964 degrees. You get 153. Yeah, 153. Okay. What's that? Negative 45. Yeah. Good. Okay, good night. All right. Here we go. Last one's for you. Here we go. Yeah, try the last one on your own, and I'll check back with you in a little bit to see how you did. Okay? A little bit, a little bit. Let me pause this second. There we go. Yeah. All right. Here we go. Let me do this, actually. It'd be better. There it is. Okay. Yeah. So first of all, did you get the right vector tonight?
I got it all wrong.
Yeah. And then after that, the formula. Great. You only went to two different places. Go to three, whichever. Okay.
Yay.
Okay. So your assignment today is like 25 questions.
Is it
That's
that homework? Is that homework or class homework? Okay.
but each thing has like. Is your daughter here?
It's 3 o'clock.
Oh,
But she has.
Two, three, four. Alright. If you get done, I'll take it.
I'll try.
What's up?
Oh, it's only 4 o'clock. Go. Bye. We have to marry.
You want to babysit my kid? Oh man, I don't know. Maybe you want to beat her first.